evaluate without a calculator, we have this sine of 67.5. So the first thing that you may want to notice here is this angle theta, if you want to call it that, is not a special right triangle, which means that if I try to evaluate this without a calculator, if I sketch 67.5, I'm not going to be able to find sine without a calculator. Last time, like I had mentioned, we looked at other ways, of finding two angles that add up to this angle, provided that they were multiples of the special right triangles angles, 30, 60, or 45. But the same thing here. I'm not going to be able to figure that out for these. So instead, what you may want to think about is try this theta equals 67.5. The other option would be to either double it or to get half of that angle. If I double this, what is 67.5 times 2? What 135. And if I sketch 135, is this going to be a special, or can I find this right here? Yes, because if I sketch 135, it's going to land over here. And remember, this is 135, but the reference angle is 45. And that's what I'm going to be interested in right now. So I know that since I doubled it right here, remember, theta equals to 67.5. So what I need to do is I'm gonna rewrite this, and the way you rewrite it is gonna help you determine which formula to use. So on this one, I'm gonna rewrite this to say sine of, instead of 67.5, I'm gonna write it as 135 degrees divided by 2. And maybe I should not have used theta here, but what I'm gonna do instead is I'm gonna look at this right here, the 135, and let's call it a different variable. I guess we'll call it u, but formulas are going to have theta, but it's like I have sine of u divided by 2, or just sine of theta divided by 2. That way you can recognize that when you go to your formulas, I need to look for something that says sine of theta divided by 2, and I'm going to use these right here. So I'm going to use this one right here, the one that says sine of theta is equal to plus or minus the square root of 1 minus cosine divided by 2. So again, formula, let me just write it down so that we know it. Sine of theta divided by 2 is equal to plus or minus, and I'll explain this plus or minus right now, 1 minus cosine of theta divided by 2. Now the plus or minus, if you look at your textbook, it tells you that the plus or minus depends on where theta over 2 lies in. I guess I should put depends on which quadrants theta over 2 lies in. And in our example, 67.5, remember theta over 2, our example is 67.5. Where does 67.5 lie in? Quadrant 1. So if I look at sine of 67.5, here's 67.5, I expect this to be positive and this to be positive, so which one should I use, the positive or the negative? The positive. So on this one, I'm going to go ahead and just eliminate that. I mean, you could put the positive if you wanted to, but I'm going to change it so that it's just the positive. Well, let me leave it as minus, so that's the formula. So now I'm going to go back and rewrite my problem and indicate that this is sine of 135 degrees divided by 2, which is a 67.5, is equal to simply the square root of 1 minus cosine of what? What's the angle here? Oops. So do I use a 67.5 or do I use the 135? 135, because remember, it has to do with, if I look at my formula, here's theta, here's theta. So this is my theta right here, the 135. So 135. Now I'm going to use my sketch that I already did for 135 degrees. It's a 45, 45, 90, so it's 1, 1, and then the square root of 2. And if I do that right here, this one has to be negative. So based on my sketch right here, cosine of 135 using the reference angle is going to be adjacent over hypotenuse. So it's going to be negative 1 over the square root of 2. Now, if we simplify this, what does this become? And the negative that. So square root of 2 over 2. Now let's go back to our problem. And let's continue writing this down. So now I have that this is equivalent to 1 minus, remember cosine of 35 was the square root of 2 negative divided by 2. I have this divided by 2. What happens with this minus and this minus? Yeah, so now I have that this is equivalent to 1 plus square root of 2 over 2 over 2. And it might look a little bit confusing because I have fractions in the numerator within a fraction. So what I'm going to do on this problem right here is I'm going to simplify it a bit, and I'm going to multiply this numerator by 2. That way I don't have this fraction down here of 2 down here, and it gets rid of this one right here. Okay. But whatever I do to the numerator, I have to do to the denominator, so I have to multiply. I'm still within the radical, by the way. So now distribute this one into both of these, and you're left with the square root of 2 plus what? Yeah, just the square root of 2 because it's going to cancel this, and then over 4. Now, if you remember your properties of radicals, remember that if I have a fraction, I can basically take the square root of the numerator, 2 plus square root of 2, and also the square root of the denominator. What's the square root of 4? 2. So I can rewrite this and simplify this as 2 plus the square root of 2 divided by 2. Now, your book, not your book, I'm sorry, your assignments, they may write that divide by 2. Let me zoom back in, sorry. They may write this divide by 2 as just a 1/2 in front of this radical, 2 plus the square root of 2. So if you look at your handout, you may see some of the multiple choice questions that they may have answers like these. But when you get to this stage, either one is correct. If it's free response and you give me this one, that's fine. Just be careful because if it's multiple choice, it might be this. Okay. It might be strange to have a radical within a radical, but that is okay. Alright, so that was for finding the sine of 67.5. Any questions?